Hello guys, welcome to Refer UX. Myself Nimesh. In this video, let's see how to configure Snort rules in CentOS 7. As you remember, in the first video, which means early video, I have demonstrated how to install and run Snort in CentOS 7. So mainly installation of Snort is CentOS is not in it's not IDS in CentOS machine, and you can view that video in the link below, even in the description I have mentioned there. Today we'll see how to add rules to make this IDS working. Before that, you need to have another installation in your CentOS machine, that is Apache server, because one of the rules we are going to check is based on HTTP, so that in your CentOS machine Apache server should be installed, and the link for the video of how to install Apache server in CentOS 7 is mentioned here as well as in the description below. You can see it, and I have a separate video for that, so please watch the video and get installed the Apache server before proceed further. Cool. Then we will see what is the format of a snort rule. Here a very simple format is there. Here as you can see, alert is the action item, so we want to alert any packet capture coincide with the rule, and the protocol we have to mention. Then it could be TCP or UDP or ICMP or whatever. Then we have to mention about source address and the source port. Then we have to set the direction. Either this is in this diagram says unit direction, you can see both the direction, putting an arrow in the other way around as well. Then we have to mention about the destination address or and the destination port. Then the rule matches, which means rule options, which means the message which should be displayed, and the flags we can put here. What are the flags should be matched, and the size of the packet received we can put as a parameter in the option. And also very important one is Snort ID, which ID it starts, as well as we can set the revision of the for this rule. We can set many such parameters here under options. So this is the format of the Snort rule. Then also we need to I need to mention about that in this tutorial I will be viewing the log file of the rules, and so that whenever the it's not detect the rules, it will be giving the output. So to view that output, this is the command available. -a represent as the we are in the alert mode, and console means it should be displayed in the terminal. -q is uh, we are not showing any banners or whatever the other information related to the it's not just the outcome only. And -u and -g means we are running the user and the group that this is running, and -c means which configuration file tally with the rules, and -i represent the interface that we are going to do this thing, that is ENS33 in my VM of CentOS. And today's tutorial, we are considering these 10 scenarios, mainly which is commonly available in a lot of networking environments. So we'll see one by one properly how to see the Wireshark traces and the Snort outcome as well. Just before starting the tutorial, I just need to mention another important thing. That is, you all know that when it comes to ICMP, the header is generally 74 bytes length. That is a maximum transmission unit size. It consists of Ethernet header of 14 bytes, and the IP header of course 20 bytes, and ICMP header inside that's 8 bytes, and the payload default one is 32, and altogether the MTU size becomes 74. So that is why as mentioned in this black image, when you send a ping message, default size is 32 bytes. The 32 bytes is ICMP payload size. So overall packet size would be 74. And in the below image you can see a Wireshark trace, and you can see the length field normally representing the MTU size. So length field is 74, means all addition of all these headers plus the payload. However, when come to Nmap ping scan, the specialty of that ping scan is they send ICMP packets with zero payloads. That is why, hence, the MTU size would be 42, and that is why it is in the Wireshark trace in the below shows the length of the packet is 42. The initial packets end by 101 to 106. So and the even that is why in the rule that we are applying to capture the Nmap ping, we says the D size, which is the packet size which is received by the destination should be that is packet size sending in this Nmap scan is 0. This payload, which means the payload is 0 in this Nmap is ping scan packets. ICMP packets. So why I'm saying this thing during the video when come to Nmap and ping scan, I'm trying to show you the length, but I couldn't find it. So this is the answer. So it is available in the length field. That is when you analyze the IP ICMP packet payload, then only you can understand why it is 42. In the video also it is 42. You can see clearly. That is because the payload is 0. That is the only way we can understand ICMP payload size. So with that note, keep in mind that, and we will start the tutorial. Start with today's lab. First of all, let me show you the scenarios that we are going to test today. These are the 10 scenarios that we are going to test today with the Snort IDE, IDS introduction system. And also there's one more thing. In the previous video we have described I have described the steps to be followed in order to install Snort IDS in CentOS 7, and today we are going to add these rules and test how it works. And before starting this, I have already installed Apache Apache web server into this CentOS machine, and let me uh, show the status of the Apache server I have installed, and you can see it's active and running nicely. Why we need Apache server? Because there's one scenario here under D that we are going to test HTTP atoms over the server, so that we need Apache server installed in CentOS. And I have a separate video on installing Apache server into CentOS 7, so please watch it first and install it first here before moving forward. And also I have opened up my Kali machine as well, because through this machine I'm launching all these kind of scans towards this my CentOS server. That's the setup that we are going to follow. And before proceeding, I will check my home network using ifconfig command, and you can see I am in the 192.168.8.0 network. And let me check what is the network that I have configured in the Snort configuration as a to work Snort as a NIDS mode. To check that, I'm going to gedit /etc/snort and /snort.config. And when you open it, I'll open the numbers for you as well. You go to line 45. You can see that the home network is 192.168.1.0 network, but today I'm in a different network, so it's 8.0. So I will change this configuration to 8.0. So now I'm monitoring this 8.0 network, and then I will save it, and I will close it. Oops, what happens? Okay, first let me change my mode to super user mode, and then alright, I'll give a password. Then I am running again this command, that is gedit /etc/snort and /snort.config. Then I'm going to line number 45. I'm doing this change here to 8. Then I'm saving this. Alright, cool, we are good to go. Then I'm going to do is very important thing. I have done some changes to the configuration file, so I have to run the configuration file again. So run the configuration file. It's not. Let me clear the screen for you. First, it's the configuration file to compile again. It's not -t and -c slash etc slash snort and snort configuration. And voila, we have successfully validated the configuration. Cool. The next thing I'm going to do is I will open another terminal. No, I'll open another tab actually. Then this tab is very special tab because I want to use this tab to view the log file, so that whenever a scan detected by IDE, the output should be displayed from the log file. So to do that, what I'm going to do is I will sudo and, give my password, clean the screen, and the command to view the log file should be uh, it is tail. Why it is tail? Because I'm really always asking to read the latest lines adding to the log file. The command should be uh, well, we cannot, sorry, not detail. It's not let me say sudo snort and -a. So we need to make in this console mode, and we are adding this rule, and I want to run this as in the console. So console output should be displayed. And so I'm using not the tail command. I'm using this another command so that I will be showing all the entries in the log file here using this command. And also I want to check one more thing, whether which interface my IP has been achieved. It is ENS33, so that is important. Then I will be adding user name as snort, and the group as also snort. And then what I'm going to do is I'll read the configuration file from CAS snort, and because this is where the command has been given, and the interface would be ENS33. So that is ENS33 comes from here, and now I'm going to press enter. Oops, all right, there's some issue here because there should be a space before the append thing. Right, now this is in the ready mode, so it's waiting until alert has been occurred, but we haven't given any rules yet, so it can't read any alert. So our next task is moving to the editing the rule file. Here we are editing the local rules, so what I'm going to do is edit slash snort slash rules slash local rules. This is where I'm going to enter the rules. So if you couldn't get the commands gedit etc snort rules and local rules. This is where we are running our customized rules. So our first scenario would be detecting ICMP attempting, that is ping attempt to the server. So the rule is I'm going to alert. What I'm going to alert is ICMP, right? Which are ICMP from where it's coming from, anywhere to any port, but towards my server, that is 192.168.8.10. What is my server IP? It is let me check it again. I'll quit this, and it's ifconfig. So it's 106. So I'll put as a 106 here, and the port should be any port if it is ICMP traffic coming from any port. So now my message would be MSG for the message is let's say as ICMP traffic detected. This is a message I want to be displayed, and you have a semicolon to every two parameters. Then our snort ID would be I will start it as sun 0000010, right? So this is one five zeros 10. All right, this is where I'm going to start, and then I'll make the revision as revision 001. So this is for initial revision, and again make sure put a semicolon, otherwise it won't work, otherwise it is not completed. So very simple: alert ICMP packets from any IP address to any port in the 8.1.106 server to any port. If you detect something like that, put a message like ICMP traffic detected from SID 15010. Revision would be one. This is first revision. So let's save this, and just remember one thing: after putting every configuration, you have to do a very important thing. That would be you have to run the configuration file again in order to make that rule uh, validated. So now the rule is the new configuration is validated, and I will run the what do you call log file reading here activated. Now I will launch my first trace, that is ping trace towards the towards this thing. And as you can see, obviously this is dot one. 8.1 means from my home computer, not the home computer, actually this is from the router. 8.1 is router, and the one that I'm going to do is I'll open the terminal, as well as I will open the Kali Wireshark trace to show you Wireshark trace. I open the Wireshark, then I'll put a filter. I want any packet related to IP address 192.168.8.106. These are 106. Yes, correct. What I'm going to do is I will activate this and I will run this, and okay, now this is activated. Now I'm going to do is I will run a ping packet, that is ICMP ping. I'm just using only 4 ping packets towards 192.168.8.106. I send it, and we have nicely sending 4 ping packets in the Wireshark. You can see also here, you can see that there are ping packets destined to 106, that is one ping, and so this is one ping echo reply. There should be a request as well. So let me do one thing. I will initiate, I will make it as to IP address to destination IP address, and so that it is be really easy. So I'll put as IP actually destination IP address would be equal this one. Run this thing. You can see that from 101 is my Kali machine, and 1012, and if just for information, let me show my Kali machine's IP. If I say IP config, the Kali machine IP is 101, and this is the 4 ping traces. And you can see from 101 to 106, there's a ping request and reply, and there are the ping request coming. Because the destination is this one, so I haven't put any uh, this is towards the destination. He has sent some ping messages, and if I say this node, you can see that from 101 there are 4 such messages has come. So this is important. This is where your rule worked properly, and you can see that I have put a rule saying that capture any traffic coming towards 106, and my home gateway also try to ping the server. That is why this continuous ICMP traffic coming. However, this is what I want to show. My Kali machine has sent some ICMP packet purposefully, and as per my rule, it has been detected. So that is the first rule we have done. And let me go to rule for the second one. So the second one, I'm going to rule file. Then to it, I'll copy this thing first. Then what I'm going to do is I'll make this a hash so that it has a comment now. Now ICMP rule won't work. Now I'll add the new rule. The new configuration would be FTP attempts. So what I'm going to do is my packets would be now FTP, and it should come from any actually FTP also coming under TCP protocol. The protocol will be TCP and it's okay from any destination, any port. But towards 106, towards actually FTP. FTP is coming to port 21, so I'll make it 21, and I'll make it as FTP traffic detected. So I'm making as FTP traffic detected, and I'll make the SID to here as 20, and the revision will be so. So now we have only one rule, that is for the TCP traffic only. So I save it and I close it. Then the important thing, I will run the configuration, compile the configuration file again. And I can see I haven't detected any new ICMP traffic. So I'll make it so clear. I'll close it, and then what I'm going to do is I will clear this. Then I'll run the scanning again. All right, now it's waiting for the FTP traffic. So I'm going back to the Kali machine. Then what I'm going to do is I will here I will copy this and I'll make an IP address simply. All right, IP address something like this. All right, let's run again. All right, cool. Towards IP address this thing, anything would be captured. Now I'll open the terminal. I clean this for you. Then I'm initiating some FTP traffic. It is FTP space my IP address 192.168.8.106 and FTP session, even though FTP server is not there, so that FTP session try to initiate it, so that if you see the Wireshark, you can see you have sent some TCP which is from the port 21, which means that you have tried to send one TCP FTP packet on a TCP protocol. This is one that is towards port 21. This is the first packet. No reply comes because there's no FTP server running on Snort. However, as per your Snort rule, you have got one detection, that is you have detected FTP traffic from 101 port 5367 S4 towards the port 21, assuming this Snort is the server 106 has detected. This is the proof where you have clearly put a rule to detect FTP traffic. Great. Now we will move to the third one, that is SSH attempts towards the server. Again, what I'm going to do is I will go back to my terminal and I will go to rule file. Then I'll add another rule. This rule this time would be for the SSH. So what I'm going to do is I will make it a comment. I'll put the third rule. Third rule also SSH will work in the port protocol TCP. However, SSH port, as you know, the port 22, and I'll change this as here SSH traffic detected, and the SID I'll make it as that. All right, let's say it's work, and I'll save this, and I'll run the configuration file so that no errors detected. And here, as you know, for the FTP we have put 20 here. We put 20, and let's see whether since I have reconfigured the new rule, so I'm going to close this and I'll run it again. So here, since it's FTP, it's 20, and if we for the SSH, it should 30. SID should be here. I'll go to Kali machine again. Then I'll stop this and I'll run this so that in the new fresh start. Then I'll open my terminal. Then I initiate I'll exit here and I'll initiate what do you mean SSH session. So SSH It's a student machine at 192.168.8.106. So this is a session I'm going to start, and yes, I want to start session, of course, and the password would be cool. Now I'm officially in the Snort machine, and backend you can see a couple of such packets going on. The first packet from 101 to here from port 22. The port 22 is the SSH. This is a proof that I have the Kali machine has sent a SSH packet. And if you go to Snort, you can see a couple of SSH traffic detected coming from 101, the port 47448 towards port 22 in the Snort. So this is how you can detect SSH traffic coming to your server, and as you can see, the SID is starting from 30. So exactly working as per our rule given. Now with that, we can move on to the fourth session, that is on HTTP attempts towards server. And again, I will stop this. I'll clean this for you. Then I'll go back to my rule file. Again, I'll open the rule file. I'll enter my rule here, and I'll make this a comment. Then I'm trying to send HTTP traffic detection parameter is also TCP, and the HTTP should come for the port 80. All right. The message I will change as HTTP traffic detected, and SID I'll make it as port. This is a rule. Traffic coming to port 18 is send server. I'll save it, close it. Very importantly, I run the configuration file again, successful. Then I'll go to the other tab, and I'll run the alert log file to wait till alert comes. I'll stop this, run it again. Okay, then I'm open the actually in this time I'll open the web browser. Then I'll try to access the server. It's 192.168.8.106, and let's see. Okay, very nice. And now I have opened the home page of CENTOS machine server. That is this is customized, and I have done. And if you view my video on Apache server installation, you can see how you can learn how you can do something like that. And also in the backend, you can see it has detected some traffic towards 101 to 106 Kali to CentOS under port 80. This is obviously the HTTP traffic. And if you go to Snort, you can see that there are some traffic coming from 101 port 521116 towards port 80. That is the HTTP traffic, and the SID starts from 40. So this is the way that you can add rule to detect HTTP traffic into your Snort. And with that, move on to the fifth one, which is the Nmap pin scan towards the server. All these next six scenarios are based on Nmap network mapping utility. So we'll move on to that. Again, I'll make it stop. Then I'll go to the rule file. Then I'll add the new rule. And very good here. I'll make this right. Then what I'm going to do is here, and here what I'm going to do is I will add a nmap. My scenario is nmap pin scan. So nmap also has a different scanning type. The first one I will use from the nmap pin scan to check whether live host in the network. To do that, the traffic is mainly nmap ping is the ICMP here, and it can go up to any port actually. Nmap pin scan, and also I will change this parameter as nmap nmap pin scan detected. So I'll make a nmap pin scan detected, and SID should start from 50. And that's very important thing. In the nmap pin scan, nmap send traffic with empty payload, so that there's another parameter we can set to intercept this traffic. So the D size, the packet size shall be 0. So capture any packet with D size 0 and name it as this message. Okay. Nmap packet detected. So if this criteria matches as well as D0 detected, then and detect those packet and name it as Nmap ping scan detected. So that is my rule to Nmap ping scan. I save this. I run the configuration file again, and oops, error has been there. Okay. Let me open the roll file again. Let's see what is the error. Uh, it's error says that can't find the. Mm-hmm, I oops. Did you see the error that has done? A very silly mistake. I have set two protocols which cannot be the should be any. All right. So I'll close this. We'll run the configuration. Voila, it works. Well, we'll go to here again. We'll run the monitoring mode again. Then I'll go to Kali machine. I'll stop this. I'll run this again. Then I'll open the terminal. Then I'll clean the terminal for you. Then I run the uh, wait. There are a couple of messages. This it detects the messages going to the send server from the 8.101 as well. That is a ping to check whether these are live. So what I'm going to do is I will run it again. Then I'll run nmap minus the command is minus s capital P and then my 192.168 dot 192.168 dot 8.102.106 actually here and in Nmap is pin scan if you remember if you know it it uses different set of packets like starting from ARP packets access restriction protocol to TCP sync TCP ACK. So it uses several protocols to check whether and all the hosts are live. So here since we are in the we have another search for the TCP scan, so I'll omit uh, we have different all these scenarios here, but in this case for the the first the packet that's in ARP packets, so obviously it's done it, but I will remove the ARP resolution here so that we can go with the TCP sync can act so that it is easy to detect. Otherwise very if you use ARP or if you use blindly, there will be ARP packets generating from all these 256 machines and flooding the network, so we can't easily do our identification properly. So I'll disable the ARP ping here. ARP. So now I'm not sending any SSH protocols. So here a couple of such packets are already going, so I'll close this. I'll run it again, and soon after that I'll run this command. Oops. Nmap is not found. Why is that? So does you ah you know what's happening here? I'm still in this Linux machine. How come that is possible? That is all these things happening. That all these couple of messages coming. I'm still in the CENTOS machine, so I need to get out from that. All right. I want to exit. All right. Cool. Now I'm there. All right. How silly I am. Right now, cool. We are good to go. And now I'm sending Right, again I need to run that command, nmap minus s capital T, my IP, and I need to disable the app. Minus disable uh, oops, open. Okay, what is the error here? Hmm. Oops. Come on, Nimish. Yeah. Right. We have launched the Nmap ping scan, and you can see one host is live. And also here I have, because the one host is obviously we have launched Nmap ping scan towards this 106 only, and we haven't sent any ping. So we have only sent TCP sync. So we'll check whether we have received that. So while soon I run this thing from here, ICMP because ping no ICMP echo request gone, and you can see that after that they have sent some TCP sync and ACK messages also towards that, and also again TCP message has been given, has been sent uh, to TCP packet has been actually here we have, can see that we have received a reply message saying destination unreachable. So when you read something like that, definitely the host is live. So you can see this is what I want to show, that the machine. Okay, I'll run it again, and I'll close this thing. Quickly run the command, and you can see immediately once when I run this thing, it sends one packet, ICMP packet here. Other than that, he sends some TCP packets as well, and we get an unreachable message from 106, so which says the host is live. But if you go here and my oops, yes, and you can see that I have run the nmap command, nmap ping scan twice. As you can see that two ICMP packets under nmap ping scan detected. And let me show one thing, that another one, I told you that this packet size is generally 0, and I'll send this thing, and here the packet, and you can see that line 5. Okay, and here we have a 0. Um, so identification in the ICMP is here showing you that it's totally a 0. And we have see that the field is the packet here sent by the nmap command is the packet size obviously is 0. As you can see that destination, can see that the packet going there. We have here in this case identification, and the packet size, where is the packet size? uh, um, well, you can check the packet size. I can't find it here. It should be 0 because that is why Nmap pin scan is not saying it's not sending any payload there, so it's obviously a 0. That's why in the parameter we have sent it as 0, and you can see that it has been detected the ending scene scan. So with that, we'll move on to the next one, which is called Nmap TCP scan. To do that, what we can going doing is so that's why obviously here uh, stream index 0. So obviously there should be somewhere that you can find out the payload of the ping packet, so that it should be 0. Okay, and you can see all the flags are also 0. That's a different thing. And all right, you can find out that. So obviously it's 0. And however our rule works, it is nmap scan and under 50 detected. Right, we then move on to the TCP Nmap TCP scan. And to do that, I'm going to I'll first of this, and I'll go to rule file, and then I'm adding a rule here, uh, which is here. Okay, and this command, and what I'm going to do is now my requirement is adding a rule so that I can detect the TCP scan, and to do that. Normally TCP syncs can also coming into TCP format, TCP protocol format, and obviously most of the time TCP sync scan is targeting port 20. It could be many places. So in this case, I'm targeting port 22, and I main as TCP. Then have TCP scan, TCP scan detected, and I'll in this there's no D size is not 0 there, and I'll make it as 60 here, and revision 1. All right, then what I'm going to do is I will save this, I will close this, I will run the configuration. It is success. Then what I'm going to do is I'll run the monitor mode again, and I'll come to Kali, and I'll run it again. Then I'll go to the my terminal there. Then I'll run the command as nmap. In this case, very simple. There won't be any disabling ping. Only thing is TP sync is minus capital T, and you can simply run it, and you can see some backend, some packets are being captured, and the scan is running, and you can see that soon I run the scan. It's in TCP packet, TCP sync, TCP sync packet, uh, and you can see that uh, it's running. And why it is getting so much time? Because it is running this to all the ports. So let me clear this specific port. Let's say minus P 22 and port 22, and specifically it's run on the port 22 now. So it scan got faster. So I'll close this, I'll run the command again. So again, okay, detected. Now you can see that you have a runner TCP sync scan towards port 22, and you can see the TCP. What happens is you are sending a sync packet, and you get and also you send a ACK packet as well. And soon after that, what you are doing is you are sending a reset packet. Soon you realize that. So this is kind of you can see that only two this after TCP can act the what do you call 10 here there's a one packet is missing. So what I'm going to do is I'll pause this thing, I'll close this, and I see entire trace. So if you see entire trace, what happens is you can see that so 101 right here you can see that. Okay, you can see that from 101 to 106 TCP sync packet has been given. Then 16 101 series to 101 they have given okay reply sync app. So and what it does is uh, soon so here it is all coming under one transition. So what it does is okay he sends okay ACK, also soon after sending ACK he sends okay I don't want this connection to reset the packet. So now they try to make a three-way handshake with the server, and they reset the connection. So that's happened, and we'll see whether it is detected. You can see that as per the given condition, my IDS, Snort IDS, detected TCP sync scan has been there. So we have completed this part as well. Now we are going to Xmas, Christmas scan, or rather Xmas scan. I'll clear this. I'll go to rules. Then in the Xmas scan, the why the first question is why we need this much of scans. That is because our network is not that much open. There could be a lot of firewalls and a lot of protection devices to prohibit scans. So in that case, all the most of them are role based. So we try to play with the protocol, play with the flags using different scans in order to get through to the towards our servers. So in the fin also another nice scan. There it is a TCP based, and here we will target towards the 422. And what happens is it is a we'll say Xmas scan is only three flags will be up as per like Christmas tree, like F P U flags only, that is fin, push, and urgent packets. Xmas scan, and specifically it detects should some of the flags. The flags would be F and P and U. Those are the flags should be detected. FPU. So and I think this should start from I would say that 70 from 70. All the if SID started from 70, it should be Christmas packets, scan packets. Okay, so I close this and I run this and no errors, and I'll run the counter mode again. Then I'll go to my Kali machine. I'll okay, I run this again. Then I'll put right before that. Okay, I'll go to here. I'll clean this. I'll run this. For this Christmas, I just need to put capital X here, and the port also given. Then I run this, and you can see Christmas attack has been launched, and port 22 is open. Then I'll close this. I try to understand where is my first initial packet from 101 to 106 here. Very good. You can see that this is the first TC Christmas packet send. You can see only fin, push, and urgent packets are there. So this is only to this is a screenshot that you can put any verification. Okay, I have launched Christmas scan, and in this note you can see that Christmas scan has been detected because the packets coming with that with the those those flags is now detected under Xmas scan. So I'll cut the session. I mean, what cut means I'll clean the session, clear, and I clean for you. Then I'll go to the next one. The next one is the fin scan. That is, we can run a scan with finished message flags only. So I'll go here. Again, I'll add a rule, my next rule, and I'll add this rule. I want this rule now. And my fin scan, of course, again I am launching. It's a TCP based port 22 base. In this case, I'll set as fin scan. Okay, then here only fin means only F flags would be activated. Let's see whether it is activating. Okay, and close this on the compilation configuration, and I run the monitor mode, and I go here again. Right, continue again. So here I'll run my command left. Right, so F is fin scan has been launched, and I stopped, and you can let me. Okay, this is the one. As you can see that from 101 to 106 TCP stream has been gone to 222. Only fin packet is activated. See, this is why how you launch the fin scan. And if you go to Snort, you can see that fin scan has been detected. This is how you can write a code command to rule to identify a fin scan. All right. All right. Then the ninth one, that is null scan. Null scan is obviously we are sending empty packets. Okay. And to do that, we can say as there's a null packet since the flag also zero. There's a flag we are saying is zero, and that is their payload was zero in the Nmap scan, ping scan, as I mentioned earlier. And to run give the rule here, I'll go rule file. Then what I'm going to do is I will oops, I will first copy this, then I will put a make it comment, then go here. It's a TCP again. Actually, the null is a TCP port 22, and I make it as nmap null. Then I flag would be zero flag. Okay, and this one I will make it as okay, it should be 80 actually. I will make it as 90. All right, so 90 save, and I will run the configuration. Okay, cool, and run the monitor mode again. Then I go to Kali, start it again. All right. Okay, here I have to enter capital N to run. Very simple. Uh, now scan. Now the scan has been given. I can see that I'll stop this scan. So from 101, you can see that with the flag 0, it's a null. So null is flag 0 port 22. This is how you perform the null scan. And if you go to IDS, you can see it's not says that okay, null scan has been detected. Wow. So you have completed the ninth scan, and final one is UDP. This is one of the also famous scan, the UDP scan. And there, what you're going to do is we go to Snort rules, and first I will copy the rule, and okay, and here actually the protocol would be in this case UDP. All right, UDP. Then what I'm going to do is here UDP to port 2, and I'll make it as nmap UDP scan detected. Here the flags there's no flags. Only thing is a UDP packet has been there. So and I make it as alright, cool, close, and run the configuration, no errors. Then I went on to the final monitor mode, and go to the Kali, scan this scan again, and I will here I will send it as W. Oops. And it has been given, and I'll stop it. As you can see from 101, okay, 101 we have a UDP packet has been given, and the reply comes as ICMP. So UDP for 222. So this is a UDP scan proof, and you can see UDP scan detector. So this is the way that you can write the rules in Snort IDE to different scenarios. In this case, we have considered only these 10 scenarios. So you can consider many. This is only unit directions. You can consider bidirectional in any ports. You can play with the port source ports, destination ports, source addresses, destination addresses, protocols, and other flags. It's a very huge area that you can play. So try with your own, and if you have any issues, just comment in the comment section so that we can try to settle them or solve them as much as we can. All right. In this tutorial, we saw how to implement or rather configure Snort rules in local rule files, and we have checked a couple of scenarios which are commonly used in network environment. I hope you learned something out of it. If you learned something, please do like and share. If you want to know about future similar videos or in similar domain videos, please do subscribe to us. Till we meet again, have a nice time.